Why buy when you can build? So, when the LEGO Optimus Prime set was announced back in June 2022, I decided it was time my McLaren Senna got an upgrade since it was the only set I had at home that wasn't a custom build. So to one up LEGO, this car would need a complete redesign, proper steering, active aero, a drivetrain, and should still be able to transform with minimal detachment and reattachment of the parts. Now, I've built a Transformer back in 2017, which was pretty shit aesthetic wise, cause I was really young at that time. So the current design should look as sleek as possible. Also, the lights weren't part of the original design at first, until I learned electrical circuits in engineering. So I'll talk about it later. Now, the first problem was the legs, or more specifically, them grippers. Cause it had to be large enough to stabilize the entire robot, so I built them in such a way that they would horizontally unfold into the car's skirtings and vertically fold during deployment. Also, I added double-sided tape underneath for extra grip. Problem number 2 presented itself after I built the legs folding mechanism, which originally was designed this way to create longer legs, but eventually I switched it up by moving the point of rotation backwards to create shorter, more stable legs. So most of the joints and hinges were locked into position using Technic rods as quick locks to enable easier and quicker deployment. The drivetrain was powered by one pullback motor for each wheel to eliminate the need of a differential, while the active aero spoilers used a bevel gear system to create active aero similar to the Pagani Huayra. I'd say the hardest part of this build was the steering mechanism, as I needed both wheels to interlock in car mode so rack and pinion gears could control it. And it needed to split apart in robot mode, as the wheels were part of the arms and should move independently from each other. Now all that's left were the lights, which included headlights, brake lights, reverse lights, and signals, and the horn. Also, in order to ensure the lights weren't shining everywhere like this, I used this build as an excuse to eat a bunch of cookies and wrap the reflective wrapper over each light, ensuring that it'll only shine in one straight direction, just like in an actual car. For better understanding, here's the circuit diagram. Both the horn, headlights, and reverse lights will be controlled by slide switches and buttons, while the blinking of the signals were controlled by an RC circuit and one half of a 556 timer.
This is not the proper explanation, but in summary, an RC circuit charges a capacitor, which disables current from going into the light, and then discharging the capacitor after a certain threshold, which supplies current to the light and turns it on. The blinking light's frequency depends on the values of the resistors and capacitor.
The LED flashes at around 0.714 Hz or every 1.4 seconds. Now, the way the brake lights turn on follow a regular car and is done by using diodes that allows only one direction of current to flow through. The two brake lights activate when the headlights are switched on, but not the third. The third brake lights only turn on when a button is pressed, simulating the driver stepping on the brakes. If the headlights are off, then the button turns on all three brake lights. Yeah, and that's kinda it.